In this video, we're going to look at solving trig equations. Unless given an interval to stay within, we're going to express our answers using an n as an integer notation. And we're going to do all of our solutions in radians. Now, let's just jump right into an example, and I'll show you what I mean. Now, also kind of in the back of your mind, when we did the graphing, sine and cosine have a period of 2 pi, which means that if you find an angle and you go either counterclockwise or clockwise 360 degrees or 2 pi radians, you land at the same spot and it'll have the same sine or cosine value. Tangent was restricted to a period of just pi. That was the horizontal distance between the asymptotes, or the distance it takes before the values of tangent start repeating. Okay, now in this first example, we're asked to solve tangent of x plus square root of 3 equals 0. Alright, first thing we're going to do is I'm going to subtract square root of 3 from both sides. And then at the bottom of the page, tangent is equal to negative square root of 3. You'll also want to keep your unit circle handy, the one that has the tangent values. You'll be able to find that in your Google Drive folder. Okay, so let's take the unit circle. The angles where tangent has a value of negative square root of 3 are these two, steeply sloped with a negative orientation. Now, one of these angles is 2 pi over 3. And the other one, which is down in quadrant 4, is 5 pi over 3. If you notice, the distance from one to the other is 180 degrees, or just simply pi radians. That top value of x, where we have 2 pi over 3, if we put an integer angle generator on it for using the period pi, and this is how it looks, that means that any rotation of 180 degrees or pi radians, they mean the same thing, you will get to another angle that will satisfy this equation. So I'm going to take off the 5 pi over 3 because it is covered by this pi n angle generator. If you take 2 pi over 3 and add 1 pi, that will take you to quadrant 4 down here on your unit circle, and it will put you at 5 pi over 3. So with tangent, identify the first angle, which was 2 pi over 3. And then from that angle, just do a plus pi n, and that will cover every solution to your equation. In this equation, we're going to add cosine x to both sides. If we add cosine x, that gives us 6 cosine x plus 3 equals 0. Subtract 3, divide by 6. Negative 3 over 6 reduces to a negative half. Remember from your unit circle that cosine is the x-coordinate at any angle that's labeled. The first angle we get to where cosine has a value of -1/2 is this angle, 2π/3. Another angle where cosine has a value of -1/2 or an x-coordinate of -1/2 is down here at 4π/3. Now, on the previous example, we were working with tangent, and those angles and values start repeating after just simply half a rotation, a period of pi, if you will. Let me clean this arrow up real quick. Make it look somewhat decent. Okay, good enough. Now, from the graphing, sine and cosine have periods of 2π. So from that first angle, 2π/3, we would have to go a full rotation instead of a half rotation. From this angle, we would have to go a full rotation. So what that tells us is, instead of doing a pi n like you do with tangent, we have to do a 2π n with sine or cosine. And that's why I was telling you earlier in the video to keep in the back of your mind that tangent has a period of pi, but sine and cosine have a period of 2π. You have to go full rotations with those. And so for this problem, your answers would be 2π/3 plus 2π n and 4π/3 plus 2π/n. When you enter these into WebAssign, just separate them with a comma and you should be fine. In this example, let's add 4 to both sides. Divide by 16. 4/16 reduces to 1/4. By square root property, take the square root of both sides. Cosine will be positive negative square root of 1/4, which will give us cosine x equals plus minus 1/2. There are several locations for these. The angles where cosine is either positive half, that's these two, or negative half, which will be these two. And I'm purposefully doing different colors just to highlight them all. These are a lot of angles to think about. Okay, the very first one we reach is π/3. Because the one marked in red is only half a rotation away, we can get away with just doing a pi n rotator. The one in blue is 2π/3. The angle marked in green is only a half rotation away as well. So instead of doing a 2π n on this particular problem, we can get away with just a pi n, because all these angles are 180 degrees or half of a rotation away. Okay, so let's see. That will give us x equals π/3 plus any half rotation away, and 2 pi over 3 plus any half rotation away. On the previous example, we didn't have that luxury. The two angles that fit the initial equation were not half rotations or full rotations away. Well, they were full rotations, but we couldn't get away with just doing a half a rotation at a time. Okay, so this is what WebAssign will be looking for. And just remember, separate them with a comma. And I'm going to take and out of there. You don't even have to put x equals. I think x equals is provided. So you would type those in and just separate them with a comma. There we go. On this example, let's solve by factoring. First, note every number in the equation is even. Let's divide them all by 2. Now let's factor. 2 cosine squared, we can break that up into 2 cosine and 1 cosine. The third term is 1, so that only has 1 and 1 as possible factors. Now this has to be able to FOIL back out to a positive cosine in the middle. So we're going to need a positive 2 and a negative 1. Outer and inner have to equal that. And so they do. If you check it with FOIL method, that does FOIL back out to the 3 terms above. Set each factor equal to 0. Add 1, divide by 2. In the other equation, cosine is equal to negative 1. Okay, so find your unit circle, or refer to it. Cosine is positive half. At pi over 3. Cosine is positive half at 5 pi over 3. And the other factor, cosine is negative 1 over here at pi. Now from each of these 3 angles, in order to get back to the same location, you would have to make a full rotation. So let's be careful writing this up. Okay, our first angle is pi over 3, and since no other angle is exactly 180 degrees like the previous example, we're going to go ahead and go back to the 2 pi n angle generator. Our second angle was pi. In order to get back to that location, we have to make a full rotation. And our third angle was 5 pi over 3. And we'll put a full rotation on it. Now, if you happen to look at these 3 angles and you notice that they are separated by 120 degrees. Excuse me. Technically, you could catch them all by starting with your first angle and then generating a 120 degree or 2 pi over 3 rotation. Like that. From what I can tell on WebAssign, the 3 separate equations in the black ink, these 3 separated with commas, but you could also get away, if you notice that they are equally spaced, you can also just record that first angle, pi over 3, and then just add a 2 pi over 3 angle generator, because every time you go 2 pi over 3 or 120 degrees, you're going to land at one of those other angles that's a solution. So that's something to think about too. This one we're asked to solve, but keep our answers in the interval 0 to 2 pi. If your problem gives you an interval to stay inside, then you won't have that in angle generator. You just find all angles that satisfy this equation within one rotation only. From our Pythagorean identity, sine squared can be rewritten as 1 minus cosine squared. If your equation gives you mixed trig functions, if it's possible, rewrite those with a single trig function. Like, instead of sines and cosines, I'm just going to try to write it all as either sines or cosines. You can pick whichever one you like, and as long as you use an identity, you're going to be okay. Alright, so we've got 3 cosine squared x. I'm going to add a cosine squared x, and then subtract a 1, and that way we get all our terms on one side. We have 0, those cosine squareds are like terms, so that makes 4 cosine squared x minus 1. Add 1, divide by 4. Take the square root, positive and negative, and we're going to get cosine x equals positive negative 1/2. Just like we did on a couple of examples ago using square root property. And we also have the luxury of knowing these solutions from 2 problems ago. The first angle that has a positive 1/2 cosine value is pi over 3. And for this one, if you remember, it was 4 angles total, so we got away with just a pi angle generator. The other one was 2 pi over 3. And then if you went 180 degrees or pi radians, you found your other one. So this one was, it ended up being the same equation as 2 examples ago. If you needed to rewind the video just to double check, or if you took notes, just refer to your notes. This example has a multiple angle. Notice that instead of cosine of x, it's cosine of 3x. We're still going to approach this the same way. We're going to isolate our trig function. Let's add 1, divide by 2. Cosine is equal to positive 1/2 at pi over 3. and 5 pi over 3. So what we'll do is we're going to set this up. Be careful with a multiple angle problem. 3x is our angle. So that is equal to pi over 3 plus 2 pi n. Also, 3x is equal to 5 pi over 3, the other angle with a cosine value of half, plus any full rotation from that one. Dividing all the way through by 3, we get x equals pi over 9 plus 2 pi over 3n. Divide each term by 3. And then the same thing on the equation, the second one. 5 pi over 3 divided by 3 plus 2 pi divided by 3 n. So when you record your answers in WebAssign, we're going to need to put in pi over 9 plus 2 pi over 3n, comma, 5 pi over n plus 2 pi over 3n as your other one. Just remember to separate by commas. And any integer you can plug in for n, whether it's a -2, a +3, when you substitute an integer in for n, multiply it by 2 pi over 3, and then add either pi over 9 or 5 pi over 9, you will get an angle that satisfies the original equation. And let's do one more multiple angle. Whoops. Let me change this ink color back. Here we go. Tangent 3x equals +1. Tangent is +1 in quadrants 1 and 3, specifically at pi over 4 and 5 pi over 4. Okay, so those are the two angles within the first rotation that give you a tangent value of 1. Keep in mind, 3x is the angle in this problem. So that is equal to pi over 4. Remember, tangent has a period of pi, so we can put an angle generator of pi n on it. Divide all the way through by 3. And that gives us the formula, or all the angles possible that satisfy the original problem. This is the part that WebAssign is going to be looking for.